Hello, class. Welcome to week 2. So the first thing I'll say is I think week 1's content was probably a little more than a week, so this week's content will be a little bit shorter than last week. There'll be fewer homework questions to get through, so it's basically to let you spend the first couple days finishing up week 1 if you had lots of questions about that, and so on. So, what are we going to talk about this week? Well, this week we're going to be talking about the shapes of graphs, and we're going to review one thing we've already talked about a lot. So we're going to review talking about what increasing and decreasing look like and how we'll figure out those things. And so those dictate things about the shape of the graph. And so if you look at the sample graph I have here, you can see it's increasing there, and it's increasing over here, and then it's decreasing in this area in the middle. And so we'll review how that's connected to various things. And then we'll start talking about this new idea that we haven't talked about before, namely we'll talk about concavity, which has to do with the way that the graph bends. Okay. And so in order to maybe sort of clarify what I mean by bend, I want to show you sort of two different increasing graphs. So this graph is increasing, and this graph is increasing, in that as the input increases, the output increases. However, they're shaped differently, and that's what we're trying to get at here. And so this one we would say bends up, and this one we would say bends down. And there are a lot of different ways that you might sort of make sense of what I mean by the fact that it's bending down. But basically, you can imagine that if this were a line here and I wanted to get this shape, what I would have to do is I would have to basically pull the rod down like this. So I'm bending it down versus here, if there were a bar here, I'd have to bend it up in order to get this shape. It's worth noting that sort of both bending up and bending down are by comparison to a line, and a line, by definition, has no bend. Okay, so if you started with this line, you could bend it down to get this, you could bend it up to get that. Okay. Likewise, if you wanted decreasing functions, you could have that, and you could have this. Okay. This is, again, what we're going to call bends up. This is bends down. Okay. And so really every graph is going to be a combination of these flavors, and I should also put the no bend here in the middle. Okay, so it's going to be a combination of pieces where the graph is increasing and bends up, it's increasing and bends down, where it is decreasing and bends up, and where it's decreasing and bends down, and then possibly some spots with no bend, which is just where the graph is a line. Okay, so if you look at this graph over here, and you want to try and figure out here, over this piece, that is increasing but bending down, so that's that one. Then over this piece here, it's decreasing but bending down, so that's that flavor. I'll go ahead and label these over on the side. Now, here we go with decreasing but bending up, and then increasing and bending up. So this graph here has all four of these flavors put together. And so if you figure out both how the graph bends and whether it's increasing or decreasing, you get a pretty good idea of what the graph is going to end up looking like at the end of the day. Okay. So the thing we're going to have to decide is we're going to have to decide how to figure out which way the graph bends. Okay. And so before we do that, I want to disentangle this notion of increasing and decreasing from this notion of bends up and bends down. Okay, so graphs that bend up, whether they be decreasing or increasing, we're going to call these graphs concave up. Okay, so concave up, that just means bends up, but has no particular feelings about whether the graph happens to be increasing or decreasing. So that's concave up, that's concave up, that's concave up. Okay. And then likewise, we'll define concave down. And that, again, just means bends down. Okay. So again, if you look at this sample graph that I have here, you'll see that over here it's actually concave down for all of these values, and it is concave up for all of these values. Okay. And so right in the middle here, it switches from concave down to concave up, and that'll be something we're interested in talking about as we go through this. Okay, so let's remember how we decide about increasing and decreasing. Namely, we decide about increasing and decreasing by virtue of the first derivative. Okay. Oops. By virtue of the first derivative. And I want to emphasize here that when we go to sort of figure this out, what we really do is we sort of figure out these in-between points, like there and there, where the function changes direction. And then we go back and sort of figure out from there what directions they are. Okay. And so here I want to disentangle two separate ideas to help make the rest of this make sense. So I'll draw a graph here. Okay. And so the thing we found before is we found these things that we call critical numbers. And those are places where the derivative is 0. That's places where the tangent line's horizontal. And so there's one of those here, one of them here, and one of them here. Those are my critical numbers. Okay. Notice here there's a flat tangent line, even though sort of unexpectedly the function keeps decreasing through this. Okay. So we're going to give sort of a special name to the places where the function actually changes direction. Namely, I'm going to call both of these things turning points. Okay. And this one in the middle, it's still a critical number, but it's not a turning point. And it's not a turning point because the function's actually decreasing on both sides. So this is a critical number, but not a turning point. Okay, so if our goal is to understand the shape of the graph at the end of the day, the thing we really care about is the turning points. That is, the places where the function changes from increasing to decreasing or decreasing to increasing. But the way we find those is that we use this fact that goes all the way back to 140, which basically says every turning point is a critical number. Okay. But as a mathematician would say, the converse isn't true. There are critical numbers like this one that aren't turning points. So we have to sort of sort those out. And we've talked a lot about how to do that before and we sort of encapsulated all of this as what we call the first derivative test. All right. So we need to talk a little bit about how we're going to do this for concavity, how we're going to decide where something's concave up and concave down. And the way we're going to do that is by using the second derivative. Okay. So it's the second derivative that dictates the bend of the graph. And I want to spend just a second telling you why that's true. So if I look at a graph like this, and I draw in the tangent line here, so this is just the tangent line at that point. The thing that actually makes this point, or that makes this graph bend up, is, again, remember what I'm saying is if I sort of imagined this graph as a line, in order to get this graph, I would have to bend it up. So the thing I'm really bending up, if you like, is the tangent line. Okay. And so what I'm seeing here is this is concave up because the graph bends above the tangent line. Or if I drew an analog where it was concave down, this graph is concave down because it bends below the tangent line. Okay. And so what does it really mean that this bends above the tangent line? It really means that the derivative over here is bigger than the derivative was there. In other words, these tangent lines at these further points, they're steeper. And so what that really says, and so this is where this gets slightly confusing, what this says is that bending up really means that the derivative is increasing. And so to frame that, the derivative is increasing, that means, what does that mean? That means that the second derivative, the derivative of the derivative, is positive. And likewise, here to bend down, it means the derivative of the derivative is negative. Okay, so I want to summarize all of that for you in a table that'll just tell you everything that you need to know about how the derivatives relate to the behavior of the function. Okay, so I have here a table which will give us the derivative, whether it is positive or negative, and what that means. Okay, so let's review first derivative, positive. That means increasing. And first derivative, negative. That means decreasing. Okay, likewise, the second derivative positive, okay, so this is the new part, that means concave up or bends up. And the second derivative negative, that means concave down or bends down. Okay. Last up for this video, which is getting long, and we'll do a bunch of examples, I want to officially talk about what it means when a graph changes concavity. So that is, what does it look like when a graph goes from being concave up to being concave down? Or in this case, I guess I drew the opposite. When a graph goes from being concave down to being concave up. Okay. And so if you sort of eyeball this, you can find a spot in here where to the left, the graph is concave down, and to the right, the graph is concave up. Okay. And if you're looking for this spot, the easiest way to eyeball it is this spot happens where the graph is the straightest. And that's because at the spot here, there should be no bend in the graph, which means the graph should look the most like a line, which it does somewhere about there. Okay. And so since this graph here, it's concave down on that side and concave up on this side, we're going to give this point a special name. Namely, we're going to call this an inflection point. So an inflection point is where a graph changes concavity. Okay, so this is our inflection point here. And I want to point something really special out about inflection points. Namely, if you draw in the tangent line at an inflection point, it's always going to be the case that at that point, the tangent line crosses the graph, okay? Meaning it's above the graph to the left and below the graph to the right, or vice versa. And that, again, is because of what's happening with bend. Namely, if to the left it's concave down, then the graph has to be below the tangent line, and if to the right it's concave up, it has to be above the tangent line. So a different way you can think of inflection points is that inflection points are exactly those special points where the tangent line crosses the graph. Okay, most places the tangent line won't cross the graph. It'll stay either below it or above it, as you saw in those places. Okay, so next video, we're going to start doing a bunch of examples where we'll calculate where a function's concave up and where the function's concave down. Until next time, stay safe.